Hello, future Boilermakers. This is our live Q&A broadcast about the majors in the Department of Computer and Information Technology at Purdue. My name is Cathy Pullings, and I am your host and moderator, and would like to welcome all of you. And to the graduating high school seniors who have been admitted to Purdue, congratulations. The professors, staff members, and students who are with me this evening hope to give you some insight and information about our Department of Computer and Information Technology, which we will refer to as CIT quite often tonight. You can submit questions via YouTube chat window by signing into your Google account and typing them in. Jessica Hoya and our technical director, John O'Malley, will be monitoring the chat and will do our best to answer your questions. If you don't get your questions answered tonight, please feel free to follow up and email to techrecruit@purdue.edu, and we will respond later on. Before we start tonight's discussion, I'd like to ask each of our panelists to introduce themselves. Let's start with the professors who are here tonight. And would you please tell us your name and a little bit about the courses that you teach? Hello, Paul. Let's start with you.
Thank you, Cathy. Good evening, everyone. My name is Paul Thomas. I am a clinical assistant professor in the Department of Computer and Information Technology. I teach 2 courses every semester as a guarantee, and that is CNIT 182, which is called System and Organizational Security. That's taken by all cybersecurity freshmen. And then I also teach CNIT 480, which is Managing Information Technology Projects, which is taken by all the programs or students enrolled in all the programs in the CIT department.
Thank you. Good evening, Phil.
Hi, Cathy. How are you?
Good.
Thank you. I introduce myself. I'm Phil Rawles. I'm Associate Head for Undergraduate Studies here in CIT, and I also teach a couple of our courses that come a little later in the curriculum. So I teach our capstone network security course taken by all of our infrastructure and cybersecurity students. And then I also teach a course on advanced network services that covers things like DNS, web services, email, those sorts of things that happens a little bit before that in our curriculum.
Thank you. And we are happy to have an academic advisor this evening. Melanie, how are you?
Hi, Cathy. I'm great this evening. My name's Melody Carducci, and I'm one of the academic advisors. There's 5 of us total in the CIT department, and we have responsibility for guiding students through our curriculum, as well as helping them make choices about different selectives that they might want to take.
Thank you. We are also happy to have a current student with us tonight. Good evening, Avery.
Good evening, Cathy. Hi, everyone. I hope you're all doing well. My name is Avery O'Neill, and I'm a current sophomore majoring in cybersecurity with a minor in forensic sciences.
Okay. Just like to remind all of our future students who are watching this evening, we will often refer to the department by its nickname, which is CIT. One of the 4 majors within the department actually has the same name. When we are talking about CRT, most of the time we will probably be referring to the whole department and all of its majors, but we will do our best to be clear. This department actually offers 5 majors. First, it's Computer Information Technology. That's the CIT major within the CIT department. Second is Cybersecurity. The third major is called Computer Infrastructure and Network Engineering Technology. The 4th major is called Computing Systems Analysis and Design. The 5th major is Data Analytics, Technologies, and Applications. Okay, Let's dive right into our discussion about the CIT department. Phil, let's begin with one of the questions we hear most frequently. Would you please describe the programs in our Department of Computer and Information Technology are similar to other computing related majors on campus? And then what is the difference about our CIT majors?
I'd be happy to, Kathy. When you talk about computing, it really all begins with the hardware. So our friends over in electrical computer engineering own that sort of the space, and they're the ones who create transistors, integrated circuits, so CPUs, processors, that type of thing, as well as the folks who are working on the communication hardware components, such as Ethernet cards, Wi-Fi cards, those sorts of things. They do some software, but most of the software that they do is very close to that. So they work in the operating system space as well as in the device driver space, those types of things. So they're really all about building that hardware and those platforms on the bottom. Our friends over in computer science, they're all software all the time, but they're really focused more on the actual science of software and the science of computing. So they're working on writing new operating systems. They're working on new database storage technologies. They're working on new technologies and algorithms to put those things together. These are the folks who would develop a new programming language, who would write a compiler, who would put those types of things in place. Whereas we in computer and information technology, we're the applied side of computing. So what we do is we take all the cool toys that our friends in ECE and CS have created, and we use those as tools to go out and solve real world problems for people who have them in the industry. So if you think about that, for instance, an Amazon.com, okay, the CIT people are writing the e-commerce side of that. They're building those pieces, whereas the computer scientist would have been developing the web servers, and the ECE folks would have been developing the hardware upon which it all runs. So what's kind of nice about that is we are the place where computing and people come together. So there's often this perception that says, oh, computer people, they sit in the corner, they eat pizza and they drink Mountain Dew, and that's all they do. They hide from people all day long. That might be true for certain areas in the computing disciplines, but it is not true for anyone who's going to be in the IT space where we're located. Companies don't spend money on computers because they like to spend money. They spend money and they pay for people because they have problems that need solved. And the first part of solving those problems begins in one of the courses that Paul was talking about, where we learn how to develop the plans for those things, actually decide what the customer really needs, because it might not come as a surprise to you that there's a lot of people who don't really understand computers, even though they need them to solve their problems. So we have to be able to define those problems and then create a plan on how we're going to solve them, implement that plan on how they're going to be done, as well as maintain it and secure it going forward. So all those things are in the domain of information technology where we're located.
And one of our hallmarks of our college at Purdue, the Polytechnic, is that our students get to do a lot of learning by doing. What does hands-on learning mean within CIT?
Absolutely. CIT is a very experiential program. So the majority of our courses do have a laboratory component. I often say the lab is where the students get to go and they get to prove that I'm telling them the right thing, that things actually work the way that we explain that they work. As noted before, people in IT are practitioners. We build solutions to problems. So that means you have to not only understand the theory, but you have to be able to make it work in place in practice. And we have tremendous facilities where we work with real world applications. We don't do a whole lot of simulator stuff. And I think that's really an important piece, because especially in the areas of infrastructure and security and these kind of things, the nice thing about simulators is they're predictable and everything works right. The bad thing about simulators is they're predictable and everything works right. One of the big things that's going to happen whenever you're dealing with computers is you're going to have situations where something went wrong, right? It says it's supposed to work this way. Well, why didn't it? Okay, so you need to be able to experience those things and solve those kind of problems. That when we applied an update, something broke. So did we do a good job of planning a backup to get back to where we were on that? Like a lot of things in life, experience is the best teacher. So you're going to find those things and learn how to do those. And you get burned a time or two by not taking the time to create a backup before you try something early. And you'll find that you don't make those mistakes again going forward, especially when it really matters. And so that's one of the things that we really like to highlight about our students, where they're really, really effective out in the industry, and where our employers come back and they say, we love your students for these features. A couple of those are that they're willing to just jump in and attack any problem that they're given, because they're given opportunity to where we learned about this in lecture. Now build a solution that does this. They aren't given step-by-step instructions on how to build it, but they're given the theory behind it. How do the pieces fit together? And then they're going to go out and they're going to solve those problems. So our students are really good at having the ability to do that. They're really good at solving problems. I often am asked at conferences, and they're like, well, how do you teach troubleshooting and problem solving? Do you create problems for our students to solve? And my response to that is typically, I don't need to do that. Our students are really good at making some bad assumptions and creating their own problems and then having to go back and solve them. And that's one of the things that I think is really important to note. If you're going to be successful in this space, you really have to love computers. And you have to have that attitude that, you're going to beat this thing. You're not going to let this computer beat you. Because the most confusing and the most annoying thing created by man, most frustrating thing created by man, is a computer, with the possible exception of a teenager. If you've ever had one of those in your house, they can be a little on the frustrating side too. But you have to have that ability to go out and look at those things, break those problems down. A lot of our solutions might have 5 or 6 different servers talking to one another. And if the answer is it just doesn't work, well, then we got a problem. Students will come and say, I can't make it work. It's like, nothing works. Well, nothing works. Well, does it boot? Well, yes. Well, well, it does this, but then, okay, so something works. How's it supposed to work? What symptoms do you have? Trace back through for me. What is work? Where does it go wrong? Okay. Now then we can go look and say, what logs do we have? How can we test that? And learning how to break those things up are critical skills that are going to last you far longer in your career than you're ever going to get out of a single piece of technology that you might have in a single class. If you think about it, smartphones, there's millions of people making their livelihood on smartphones these days. We've only had smartphones for about 15 years. Hardly any of those people went to college to learn how to do anything with a smartphone, right? So they adapted to new technologies and new pieces and parts. But I guarantee you, what they went to college for and the way they learned to solve problems, solve those interconnected systems, those kind of things, is just as applicable to smartphones as it was to client server systems, as it was to mainframes, as it will be to quantum computing and everything else that comes along.
Thank you. Paul, would you please give us some examples of specific programming languages that students learn to use, or specific course topics related to coding?
Absolutely. So in our department, while we're not necessarily we're not going to say programming is all we do, we like to provide our students with a foundation where they can be successful in an IT organization. As such, we do have at least 3 courses in programming, covering Python, procedural C, and Java. And there may be more. I don't exactly teach the programming courses, so not entirely privy, but I see Avery nodding along, so I think I'm on the right track here. And the emphasis in all of these classes is more on the problem solving aspect, on the algorithmic thinking aspect, in that if you can figure out a solution for a problem, then writing it out in code just becomes a matter of syntax. And of course, some things are easier to do in one language versus another. Some languages are more in vogue nowadays compared to previously. Phil was talking recently about sunsetting a COBOL course. We don't teach COBOL anymore, but there's still some jobs out there which you can make a pretty penny with if you were to learn it. But we do keep our finger on the pulse of industry and set up our students for success in that regard. But the focus is once again on what's beneath the code. What problem are you trying to solve? How best can you effectively and efficiently do that? And some of the classes happen at a 100 level, and then there's 255, and I believe 315 are the other programming language classes that they will end up taking.
Okay. Melanie, how much experience do incoming students need to have with writing code before coming to Purdue?
Sure, Kathy. So our curriculum is designed in a ladder formation. So we don't assume that anybody comes to us knowing how to do anything. So we also have plenty of challenge built into our curriculum. So if you do come in knowing lots, there's still ways to continue to expand. So if you've not had programming in high school, you're going to be perfectly comfortable coming into our program and beginning in our 155 programming class. It's not inaccessible, and we encourage people, if they have a passion for the industry, to come to us and we'll help you build all those skills that you need.
Is it essential for students to know how to write code?
Absolutely not.
Okay.
Cathy, if I may.
Yes.
If you do have a background in code and you're going, gosh, I've taken 2 or 3 courses, either in high school or I did AP computer science, or I did a dual credit or something along those lines. And you're saying, gosh, I don't really need to take that first course on what's a variable, what's a loop, these kind of things. There's an opportunity that you can test out of that course as well. So just notify your academic advisor during your summer onboarding, and they will set you up in the fall to take that test out exam. And if you pass it, you can move straight into the second one. If you already have that, we don't need you to do it again. It's not as if it's something special, but I don't want anyone to feel that, oh my gosh, I'm at a serious disadvantage if I didn't do that. The course is designed for people who do not know how to write code, and it's an introduction to those things. So if you do, feel free to take that test out.
Okay. We have our first question from a viewer. And Melanie, this would be for you. How much computer science knowledge is required prior to undertaking cybersecurity courses? And are those taught in the first few semesters before cyber courses?
Sure, Kathy, I think we've covered that. Our introductory courses are designed for people that have little to no knowledge. And as Phil said, for more advanced people, we do have opportunities for test out. But if you feel like you don't know a lot about the industry, I think starting with us, if that's your desire, will give you a good foundation to set yourself up for success once you get into those more major specific courses for cybersecurity.
Thank you.
May I add something to that? That's okay, Kat?
Yeah.
So one thing I emphasize in the introductory cybersecurity course that I teach is we have students of varying skill levels and knowledge of cybersecurity come in. Some of them have been part of workshops, some of them have completed certifications, others have little to no experience with the space whatsoever. But with the beauty of our introductory courses is that it's not meant to be weeding them out or anything. It's to equip them with the foundation to be successful. And that said, if you feel like you already have the prerequisite knowledge, you're more than welcome to try and test out. Can say, but even then, there may be gaps in the knowledge that you will get addressed over the course of the semester, even in those 100 level courses.
Okay. Avery, let's talk about the projects and the labs that you've done. Is there one that comes to mind as a favorite example of the learning by doing?
Yes, so as previously mentioned, CIT specifically is very hands-on. You will be in the lab the first week you are on campus, which is something that is super unique to the Polytechnic in itself. Pretty much all of my labs in general have been learning by doing in the labs, depending on what the course is. I've taken courses in networking. I've taken courses in cybersecurity specifically, coding languages. All of those classes, you will take the information that you learn in the lecture and apply it to the lab. So you won't necessarily be guessing, but you're going to have a background and you're going to have to expand on that within your lab setting, which is super useful. Personally, one of the classes that I'm in right now, CNIT 344, Network Engineering Fundamentals, is very hands-on and very applicable to this question in the sense that the things that we learn in the lecture do directly transfer to the lab, and you're building on every single week. And that's something that I think is personally very unique and that I've very much learned taking that class this semester.
Good. All right, back to you, Melanie. What are the plans of study like for the 5 majors within the CIT department? And are there any courses similar during the first year, but then different in other years? And then how soon do students get involved in the hands-on learning?
So our plans of study are our degree is broken down into 120 credits. All students at Purdue take what's called a university core, which is often referred to as your general education courses. And then our students also have some additional coursework that's part of their CIT Common Core that's common amongst all the majors. Our department specific curriculum, pretty much the first 2 years of curriculum are extremely similar across all of the majors with the exception of maybe 1 or 2 courses. But once you get into your second semester, sophomore year, your junior year, then you're really going to get into the meat of your specific curriculum and start taking courses that are part of whatever area it is that you're specializing in. Now, the really nice thing is if you're not sure what area you want to specialize in, we do offer that computer information technology general degree, which gives you the opportunity, instead of having specific courses chosen for you, it gives you 15 credits of IT selective, where you can sample each of the maybe different areas and build a well-rounded case for yourself. Or if you're most interested in the programming aspect, it allows you to add additional programming courses that we offer to sort of specialize your degree in that way. But for the most part, the first 3 to 4 semesters are very similar for all of our students.
Okay, thank you. Phil, we get this question a lot in the RRD office. For incoming students, they're always asking about what computers do I buy? Can you do all of the required work by using computers available in labs on campus? And if it's helpful to have your own computer, what are your recommendations for all of the majors?
Certainly, Cathy. Yes. Can you do everything in labs on campus? Certainly could. Will you be happy doing that? And maybe not so much. We'll let Avery speak to that a little later. As far as what you should buy if you want to have something, the vast majority of our students have their own computer, and the safest bet is to get a Windows machine. Right today, as long as you get anything that's modern, i5, i7, 6th, 7th generation processor or newer, you're going to want to make sure you have a Wi-Fi card in it. I defy you to find one that doesn't, but you want to make sure that that's there. Bluetooth. The real options that you're going to have are going to be screen size and hard drive size and amount of memory. Get at least 16 gig of memory. A lot of these new machines, they're getting thinner and thinner, and the memory is soldered to the motherboard, so you don't necessarily have the opportunity to add memory later. So make sure you get at least 16 gig. There's very few things we're going to do where you would have to have more than that. But if you have less than that, you're definitely going to run into issues, especially later when you might be spinning up some virtual machines on that to do testing if you're in the software space or in the security or the infrastructure space. As far as hard drive space goes, in fact, that's probably a misnomer at this point in time. Buy something with a solid state drive. Unless you're trying to find the absolute lowest end of the market, is probably going to come with a solid state drive. But you're going to want to make sure you have a solid state drive, M2, NVMe, something along those lines. The more space, the better. I would not go for anything less than 500 gigabytes. A terabyte would probably be a good starting point for those things, because you're always going to have a need for storage and scratch space. And especially, once again, if you start spinning up VMs and whatnot, you can chew through a lot of that storage space in a hurry. As far as screen size goes, there's no right nor wrong reason there. I would say 13 inches, 13, 14 inches is probably a nice screen size for that. You get down in the 12-inch range, and all at once it gets a little small to see, and especially the keyboard starts getting really cramped, as they shrink down there. So if you're going to do a lot of typing, you're going to find that that's a little difficult. You might lose some of your directional keys that are useful when you start getting into something that small. And then if you get something really, really big, like a huge desktop replacement, that's great. But the bigger that screen is, the more battery it's going to eat to run it, and the heavier it's going to be. And so when you're carrying this thing around all day, an extra pound might not seem like much, but when you're on your 10th mile of the day, you're on that 10,000th step, it does start to get a little heavy on the back side of that. And also, once again, the bigger the screen, the more battery, and running out of battery is not fun. Fortunately, computers have gotten a whole lot better on that. As far as other things that we often get asked, do I need a cellular data plan? No, not really. Campus is bathed in Wi-Fi. You're not going to have any issues with that anywhere on our campus, unless you're maybe sitting smack dab in the middle of Memorial Mall or something where you're away from a building. You might have a little bit of difficulty. But then you could do a little experiment with one of the Pringles cans and make yourself a Wi-Fi antenna, point it at a building and pick it up that way. You can spin it into a fun computing exercise. The other thing that we get asked a lot of times is, do I need a printer? And I'm going to reply to that as, no, you don't need a printer. There are going to be printers available that you can use in all the computing labs. You get, I think it's a $40 allocation. It's like 2 or 3 cents a page to print. That you can do that. You can buy more if you need it. So from that perspective, you don't have to have a printer. If you're taking a course where you're writing a paper, personally, I find it a whole lot easier to print it, look at it there, read it, and copy edit than otherwise. So if you're not going to be living on campus, or later in your career, if you move out of a dormitory style living piece and you're farther away, it would be very handy to have such a thing. A lot of our students also will get a monitor and a docking station to use back where they're living, so that they can have a full-size keyboard that's just easier to type on and have a little bit more screen real estate to do those things, rather than always be working off of that small computing piece from just like the actual top on it. The one thing you don't need to do is buy something that comes equipped with Microsoft Office and all these different pieces of software, because the university has a license with Microsoft. You will be able to install Office 365 for free. So you don't need to pay for it up front. So if that's one of the options, if you're on a Dell or an HP configurator, don't bother checking the box and buying a license for it, because you won't need it. You'll be able to get it for free when you get here.
Bill, I'm going to ask, we always get this too, because, I know Apple's big with their products, and having an Apple laptop versus a Dell. If students do have an Apple computer, is that okay? Is that compatible for CIT majors?
Yeah, if you look at that, there's nothing wrong with having a Mac. It used to be really easy and said it didn't really matter because the Macs were Intel and you could run whatever you wanted to on it. Well, as Apple's moved to their own silicon in the M1, M2, M3 family of chips, it's become a little bit more convoluted. There are some pieces of software that you need to run Windows in order to go. Now there are emulators that will take care of that for you. And when you get into doing a lot of your work if you're going to be spinning up Windows VMs and whatnot for class, a lot of Linux VMs, this sort of thing, it'd probably be a little bit easier if you were on an Intel-based platform. But in all honesty, you can make a Mac work. The question is just what do you want to invest in? If you love Macs and you're comfortable in a Mac environment, you're going to learn Windows when you're here. You're going to learn Linux when you're here. You'll be able to pick those things up and run with that. So I'm not going to say that one is better than the other. I would say that unless you have a really good reason to do the Mac, it's probably a little more straightforward to stick with an Intel platform running Windows. And Avery can speak to that when she gets her next opportunity as well, because she's living it.
Yeah, I was just getting ready to turn to you, Avery, and for you to tell us about, the use of computers on campus in labs versus you using your own. Have you been happy with the computer that, you started with at Purdue? And then, I mean, if you don't mind sharing, what type of computer do you have?
Yeah, so I personally use a Dell XPS, and it's worked out great for me. I personally do recommend getting a Windows machine. As a student, one of my best friends on campus, he has a Mac and he has to go through like several more steps to do some things, and he just jokes that he likes to play on hard mode. But that's okay. Whatever works for him. But regarding the computers in the labs, in some lab sections and some courses, you will actually be required to use the computers that are in that lab space, depending on what the lab is. For example, in my network engineering class, we have to use the PCs that are in that room because they directly sync up to the server room that is right next door. Or even with the system administration class I've taken, you have to use the machines that are in that room because of the way that they are programmed, things like that. But then with other courses that I've taken, you will have virtual machines that you can just boot up from your own computer and you can work on those projects anywhere across campus. It's super nice because the CIT department has a CIT VPN that you can connect to wherever you are. And when you are connected to that VPN, you can access all of your virtual machines from anywhere, which is super useful so you don't have to go on campus at a late hour per se to go work on your lab. Instead, you can just do it in the comfort of your own home. But yeah, I would say it definitely depends on the class. If given the opportunity, I do prefer to work on labs on my computer just because it's easier. Things are saved locally to my computer and I always have them. But some cases that might not always be possible. But yeah.
Okay, thank you. Paul, how important is it for students within our CIT majors to learn about project management? Could you talk about how students can leverage skills like project management to gain real world experience during capstone projects or internships? And I realize capstone projects are, go when you're a senior, but if you could just talk about the project management.
Sure. So I may be a little biased because I teach the senior level managing IT projects course when I say that project management is important, but I didn't come to this conclusion on my own. We work closely with our industry partners. We, in fact, have an industry advisory board. We meet with at least twice a year and we solicit their feedback and inputs into basically how we run our programs and what they like to see in our graduates, what they want to see more of. And one thing that's been consistently been said to us is they want to see graduates have an awareness and knowledge of project management concepts, specifically in IT. Because the simple reality is that pretty much everything in IT runs in the form of projects. Now, you may not necessarily crave a project manager title or position, But the reality is that you're going to be operating within the constraints of a project, and you will be encountering project management lingo. With that said, wouldn't it be better if you knew what those terms meant specifically for you as you progress in your career in this position? So as such, a lot of our courses with that emphasis on hands-on learning is set up in the form of project-based learning as well. And uh, starting from freshman year, so in the 182 class, I have them work in teams to not only develop security plans, and again, as I say this, I see Avery nodding along. She was a freshman in fall 22 in my class there. And yeah, we have them develop organizational security plans from the standpoint of physical security or information security, but then also develop a database based on designs that they had to come up with in response to a problem that they were presented. And all the while, they need to figure out how to work with people that are different from them, maybe from a different state, maybe a different country, have a uh, maybe a completely different perspective on how teams should work together. And this is all useful because I tell my students that, well, 95% of you won't get to choose who you work for or who your team members are. You're going to walk into an organization, there's going to be existing structures, there's going to be existing procedures and policies, and we want to equip you with the skills to be able to navigate that. So, so in some ways, it's baked into our curriculum, baked into our courses, and of course, the project management course itself is set at the 400 level because we want students to go out, get experience, hopefully do an internship or two. And when they come back, we put it in context for, yeah, this is what you experienced. This is what you saw.
Thank you. Melanie, I'm gonna ask you to talk about how do students go about getting internship opportunities?
So there's lots of different resources that we have available for students on campus to help them search for internship opportunities. We, as in the Polytechnic, as well as our specific department, host 2 career fairs in a academic year. One specifically for our majors and another specifically for Polytechnic students. We also have a very robust Center for Career Opportunities on campus, which can provide students with everything from an outfit to interview in, to helping them develop an elevator pitch to talk about what they can offer to an employer as an intern, and other company search skills, company research skills, as well as a large database of companies that have contacted Purdue and said, we want to hire Purdue interns. So all of those resources are available for students. Also, it's a great idea to get involved with our Purdue IT Professionals Club. They will encourage you and give you ways to think about your experience and list it on your resume. They have resume writing workshops that they've hosted in the past, as well as hosting information sessions from different companies on campus, which is a great opportunity to meet with company representatives that is not as high stakes as an interview or a career fair. So there are lots of touch points that we very intentionally develop to help our students make those connections that will get them an internship.
Okay. Avery, I'm going to turn to you because you know, you are one of our student ambassadors in the Polytechnic. So Melanie talked about getting involved. Tell us what you're involved in on campus, and then let's talk about your internship opportunities.
Yes, of course, Cathy. So, regarding the organizations that I'm involved in on campus, I'm involved in a lot. Purdue likes to recommend students to be involved in one club at least that's related to your major or networking based, and another club that's just for fun, you know, as a stress reliever after class. So with organizations that are related to my major, I am in Women in Technology and Women in Cybersecurity. Those are both more networking focused, allows me to build professional skills and things like that. Lots of guest speakers come in and share their experience in the workplace, which has been super beneficial. I am also currently the public relations chair for the Purdue Cyber Forensics Club. I really enjoy this because it allows me to learn more about a field that I might not be able to take courses in until I'm an upperclassman. So it allows me to gain that exposure early on, which I'm super grateful for. And then for clubs outside of the Polytechnic that I do for fun, I am involved in a philanthropy-based organization where I currently serve as the vice president of operations. I have really enjoyed all of those. Having leadership positions is great. It allows you to have things to put on your resume and also just build your personal leadership skills, since everybody has a different way that they go about leading, especially depending on who you're working with and who's watching you. I also just go to career fairs regarding internships. I remember I went to a career fair my freshman year and I didn't know what I was doing, but that's okay. You always have to go to one first. Just, test it out, dip your toes in the water, and practice your elevator pitch. Just get your name out there. It never hurts to go to a career fair and just practice. Even if, you're a freshman and the chances of you getting an internship are slim, it doesn't hurt at all. I was lucky enough after my freshman year to get an internship, primarily through connections. I worked at Wintrust Financial Corporation in Rosemont, Illinois, as an IT strategy and special projects intern. It's funny that Dr. Thomas keeps talking about project management because that was the majority of my internship this past summer. And I really enjoyed it. Although it wasn't necessarily cybersecurity focused, it really gave me a greater perspective on the corporate structure and the different projects that have to be put into place in order for an entire organization to run smoothly, which I personally found very beneficial and I'm forever grateful for. I made so many connections, so many people that I still talk to today. This upcoming summer, I will be working at a manufacturing company called Integris in Aurora, Illinois, as a cybersecurity analyst intern, and I'm very excited for that.
Good. Okay. Melanie, let's talk about double majors in two of the fields in the department, or can students get a minor or a certificate that complements their major?
Absolutely, Kathy. We frequently have students who will do a dual major with our networking major as well as our cybersecurity major. Those two majors pair very well together, and I think it gives them a lot of flexibility when it comes to looking for a role once they leave the university. We have over 130 different minors available on campus, and we encourage students to complete a minor. I know Avery mentioned that she has the forensic science minor that she's working on, and that is very popular among our cybersecurity students. I think it's a great idea to pursue a minor that is outside of computing because it gives you an opportunity to feed maybe a different part of your brain. So many of our minors share courses with our CIT Common Core classes so that students can double dip and make it a little bit easier to get that minor because they're not taking so many additional classes beyond those 120 required credits. So if you have something that you're interested in, I encourage you to talk with your academic advisor about that as soon as possible. And that way they can give you examples of how that would fit within your curriculum and when and how you might want to stage those courses to make it most impactful for you.
Okay. We had another viewer question come in. Cheryl asked, and this is for you, Melanie, can CIT students majoring in cybersecurity do a minor or double major in computer science if they want more of a programming background?
I'm sorry, was that question for me, Kathy?
Yes, I'm sorry. Yes, Melanie, that was for you.
I have several students that have chosen to minor in computer science. I would say that the double major between computer science and CIT would probably be a little more difficult to pull off because the programs don't really share many courses in common. So that while it's doable, everything's doable with enough time and enough perseverance, it's probably not going to be doable within a traditional 4-year time frame. So if they're really interested in pursuing a dual degree with computer science, they might want to think about their career or their degree path is going to be 5 years or maybe 5.5, depending.
Okay, thank you. Phil, have a question for you from a viewer about study abroad opportunities. Wendy asked, how does studying abroad benefit or limit a CIT student's program?
We've had a lot of students do study abroad in a lot of different places. Australia, Europe. We have someone going to Korea. We were just talking about earlier this morning and looking at some courses there that would count for them. Study abroad is a great opportunity. Not only do you get the cultural immersion aspect, it's also just a chance to kind of do some more of that thing you naturally do throughout that college process, which is grow up, right? And get a little outside of your comfort zone and see things and do things and be put in situations where you're maybe a little less comfortable. And that's an important part of that maturation process that happens in these years. If you are interested in study abroad, you certainly can do that. And we've had people do it from all of our majors. What I would encourage you to do is if you think you might want to do study abroad, bring that up with your academic advisor the first time you meet with them over the summer before you're here in the fall. And the reason for that is if you look at it, there are certain things that are relatively easy to get anywhere, right? You can pick up a comm course, you can pick up comm communication, you can get an elective in sociology or psychology at just about any university in the world. You can't get that 300 level CIT specific course that's a prereq to the one you need the following semester just anywhere at any time. So if you're going to be interested in doing study abroad, we can work with you on picking what semester would be good for that, saving some of those courses that are going to be relatively easy for you to take somewhere else, and crafting that into a nice little package where that's going to work and have minimal impact to you on finishing your degree on time, schedule, etc. And toward that end, if you're doing your planning, most people do study abroad in our spring semester. If you look at the way the European calendars work, everyone in Europe seems to take the entire month of August off. And so classes don't start until well into September, and that first semester runs all the way into January. So if you went overseas in the fall, you're not going to be back for the start of our spring semester. And then their spring semester starts a little later and it runs into June. Well, that's not necessarily a problem. And if you're going to Australia or Peru, Colombia, Brazil, somewhere like that in South America, then their calendars kind of work backwards because of the way that their seasons run. And once again, it's a lot easier to be going in what is the spring here than it is in the fall. So Melody could speak a little to this, but most of the time we find that spring of the sophomore or spring of the junior year are the two most effective times to do that. And once again, I honestly cannot stress it enough. If you're interested, even if you aren't sure, even if you're just interested, say something up front, and then you can get advice from your academic advisors on how to make that happen for you. Wonderful opportunity. Purdue has great partnerships with a lot of institutions around the world. With those partnerships, one of the things that's really cool is you pay Purdue tuition and you get to go there, and their students pay their tuition and get to come here in those trades. So it's going to be fairly straightforward to do that. We have an entire group that works on those sorts of things, but it does take advanced planning, not only from the academic side, but there might be visas that need to be squared away and done. You're going to have to apply at that institution. And so you're going to want to get on that at least 6 months, preferably a year in advance, in order to make that work and go smoothly. It's study abroad is not something you decide to do over Thanksgiving and jump on a plane in January.
I agree. And that being said, they need to, if they don't have their passport, need to start working on their passport.
Right.
Melanie, you wanted to say something?
I also wanted to share that we have shorter study abroad opportunities that are available. If you don't have the capacity within your academic program to want to do a full semester, we have Maymester opportunities. There are spring break opportunities, winter break opportunities. So there are lots of ways where you can go and have a cross-cultural experience that don't necessarily involve an entire semester.
Okay, thank you. We had another question, and this is for you, Paul. Jay says, I watched a YouTube video talking about cybersecurity. Is there too many certificates required to apply for a job, and those certificates require annual fees? Is it true?
Okay, good question. There are dozens of certifications out there relating to cybersecurity or networking, and this is a pretty common question I get from my students too. It's like, oh, what cert should I get, or when should I start doing them? And my standard response is, if you have the time, money, and resources to prepare for and pay for a certificate and get it, by all means, more power to you. You should do that. But um, whenever I have guest speakers come in, they will say, you don't need certificates to get an internship or even get a job. A certificate is just proof of knowledge that most of the time. There are some very involved certifications where you need to show that you're able to apply the knowledge to clear that, but most of the time certificates and certifications are proof of knowledge. It may get your foot in the door, but it is no proof as to whether you're able to successfully apply that knowledge in an actual industry setting. So we tell our students, you really don't need to go out of your way for it. Our courses are not set up to get you certificates. There'll be some overlap in terms of knowledge there, for sure. But we encourage students to, get in companies and have those companies pay for it. They're often pretty willing to. They have professional development funds for that exact purpose. And the nature of certificates and certifications is that it's ever changing. What is in vogue today will be obsolete perhaps a few years from now. So it is a game you have to keep up with, but we emphasize the fundamentals. As Phil said earlier, the way he was teaching things today that did not exist when he graduated from college. I'm a more recent graduate myself, but I get to use that line too. uh, what we're teaching today did not exist 10 years ago. And that's so by signing up for this degree, you are signing up for a lifetime of learning. And this is not meant to terrify you, but just an honest appraisal of the situation. I hope it excites you in some way, that there's always going to be something new to learn. So I hope that answered the question about certifications. There are dozens out there. Some may be more applicable to you depending on your specific career aspirations. But we are never going to endorse a specific certification as a department.
Thank you. Melanie, I know that there may be some viewers that after tonight, they will accept their offer. Can you just cover what are the next steps once they do submit their offer?
Sure. Once you accept your offer and pay your deposit, you will get access beginning on May 1st to the Purdue 101 onboarding course. You'll complete that course that will contain a form at the end of it that we ask you to fill out called the Student Information Form. That form gives you an opportunity to share with us what credit you may be bringing, what your areas of interest are, where you feel like you might need additional supports. Once you complete that form, that triggers the academic advising team to know that you're ready to begin your summer advising prior to the semester in the fall beginning. If you don't complete that form, you will not receive the invitation to schedule that important appointment. So be sure that you're completing that form, and the more information you give us on that form, the better job we can do beginning your academic career at Purdue. The Polytechnic will begin those summer advising appointments on the 1st of June. So even if you complete your form on May 1st, you get your invitation, you're not going to be able to schedule an appointment until June 1st or after. Those appointments are all held virtually, very similar to what we're doing here. This evening, you'll have a one-on-one appointment with an academic advisor in the department. They will walk you through the scheduling process, and then you'll receive your schedule for the fall in mid-July-ish. Once you've done that, you sign up for BGR, you have a fabulous experience there, and then you start your academic career at Purdue.
Okay, thank you. Have another viewer question from Israel, and this is for you, Phil. What innovative research is happening in the CIT department, and how can students get involved in research?
Boy, that's a broad question. What do we have going on that's innovative? We've got stuff all over the place. We are doing work, a lot of work in machine learning and artificial intelligence, as just about anyone in a computing discipline is at the moment. We have a lot of work going on in natural language processing, as everyone's aware of, things like cover your devices here, Alexa, Siri, Hey Google, Sonos, all those kind of things are busy. And so, how do we work with those? We have a colleague who works with humor and how do computers understand humor? And the answer is they don't, at least not very well. That's one thing that is very difficult. That picking up on sarcasm for a computer or snark is a very difficult thing for them to do because they're very literal. So picking up on those context clues are difficult for automated systems to do. We do a lot of work in the networking and infrastructure space, a lot of applied research into how do we optimize these things? How can we automate these pieces? If you've been following our industry at all, there's a lot of talk about creating all of these things as services. Phrase used to be software defined networking. Now it's become instead network virtualization, everything being built in some sort of containerization piece. Instead of installing software, we're just going to deploy a container in Docker or something to that nature out to pieces. We've got work going on all of those types of things all across the board. We have colleagues in security who are addressing things on a very computer specific basis in computer forensics and whatnot, to bigger problems in the security space where computers are part of the solution, such as human trafficking. And can we use automated cameras and the like and help with human trafficking pieces, working with the psychologist and the sociologist to say, if people are being moved against their will through an airport, do they have certain tells? Are there certain things that we could pick up on that we might be able to train a machine language system or a machine learning system to pick up on? All of these kind of things fit across the board. So, and that's just within our department. Another cool thing about applied computing is we are applied. We associate with everything. Myself and my colleagues have done projects with everyone from nursing to agriculture, where we're burying sensors in the ground and worried about how do they communicate via wireless signals through the ground, which propagates signals very differently than the air that we're used to, and collect data to be more specific, to apply only the right amount of fertilizer in the right places to be more cost effective and prevent runoff that creates algae blooms in lakes and freshwater streams and those kind of things. We're doing stuff everywhere. The one of the really cool things about computing is it's applicable to everything. And that's one of the things that we really love about what we do, because we get to meet all sorts of different people with different things, and they know they have a problem and we help them solve it using the technologies that we're familiar with. In our general CIT major that Melody was talking about earlier, not only do we have those 15 credits that you can do what you want to do, we also have 15 credits to minor in something, and we don't care what it is, as long as it's not computing. So if you have some other, you love computers, but you have another interest, go minor in that other interest and go be an IT person in that other field. Whether it's music and theater. We've had people minor in theater tech. You go to Disney. Do you think Disney makes all these rides and all these wonderful attractions work without computers running it in the background? They do not. Right? So there's opportunities there. There's all these things you can do. Just look at sports, for instance. Everybody's talking about, analytics is the big thing. We're in the middle of the NCAA basketball tournament, Go Boilers Final Four. But you look at like Alabama, which is, playing analytics ball, threes, layups, and dunks, right? Mid-range shots are bad, according to the computer simulation, right? Computers are everywhere. It's ubiquitous. So you can use those in anything you want to do. Same for the research. Research going on everywhere in all those fields. And here at Purdue University, we're in the heart of all of it.
Thank you. Before we wrap up our conversation tonight, Phil, we're going to start with you, followed by Paul and Melanie, and then Avery, you'll get the last word. So what advice would you have for our future students who are looking at any of our 5 CIT majors to be successful and happy? Phil.
Advice for students to be happy and successful. My first piece of advice would be to be successful. One of the things you have to learn and be able to do in college that you may have cultivated this skill, especially if you were involved in a lot of extracurriculars, sports, theater, any of those kind of things, band, etc., is time management. You have to be able to manage your time when there's no one else to tell you how to manage your time, right? There are a lot of temptations to play games, to do different things, and you have to be able to manage that and put those things together. And the university offers some study skills and some time management courses. And if you think that that's something you might need some help with early, when you're starting to struggle a little bit with that, look for those resources, right? Don't get all the way behind before you look for the resources. So that's one thing, is being able to manage your time. The second thing is there's more to life than school. We talked about all of the different organizations, and Avery's involved with a ton of organizations and whatnot. And that's awesome. We always want you to be involved with something, especially in those computer related things. But it's also great to be involved with one that has nothing to do with computers. Man does not live by computer alone, right? Do something. If it's be involved with the Pet a Puppy Club, where you're going to go over to the student rec sports center and help with the puppies to be stress relievers during exam times. If it's you're going to be involved with the hang gliding club, or you like to play hockey and you want to be involved with the intramural hockey or club hockey team. You want to play soccer in intramurals. You want to go out and you like off-road vehicles. There's the Purdue Off-Road Club. We have over 1,000 different student clubs at this university. One of the big advantages of a large institution is no matter what kind of things you like to do with your spare time, you can find other people who have a similar interest, and you can go and scratch those itches and go out and make those things happen, and have that opportunity to disengage your brain, think about something else, so when you come back into the classroom, you're not completely fried. And by all means, go out, go to a football game, go to a basketball game, go watch our nationally ranked volleyball team, our nationally ranked basketball team, who we're hopeful brings home some more hardware this weekend. But have that opportunity to go do those things. That's probably the best advice I can give anyone, is to try to have a little balance in your life.
Thank you. All right, Paul, you're next.
So, Phil's a tough act to follow in that regard. So, I will emphasize community in terms of finding community for yourself while you are at Purdue. And on that, I'm going to put a plug in for the cybersecurity learning community that we're starting up in the fall 2024 semester. And seats are limited. It's for right now up to 50 students maximum. So, if you're interested and you're a prospective cybersecurity student, uh, well, accept your offer, fill out your housing app, and then go on learning communities to express interest in joining. And if you're wondering what a learning community is, it's a group of students who will live together and learn together and experience a lot of activities together, uh, ranging from game nights to community meals to also where so I'm running this community, so I also plan to bring in speakers from industry, so they get to build both professional skills, technical knowledge as well, and get an understanding of what the space is all about. But even outside of that, just adding on, I'm also the faculty advisor for the Ethical Hackers at Purdue Club, and that may be something you're interested in as well. Or like Phil said, maybe find something not computing related. Uh, Man does not live by computers alone. Absolutely. There's also, I tell my students this, your classes are important. Your first and foremost responsibility is your education. But if that's all you do, you're missing out on so much of what college has to offer. So I encourage you to explore those opportunities as well, but don't skip your classes. You're paying a lot of good money for this.
Thank you. Melanie.
Well, Kathy, I have this conversation often with my students, and one of the things I tell them is that they are never again going to be in an environment that is as rich and varied as the one they're going to experience at Purdue University. There are opportunities to interact with people from hundreds of different cultures. There are opportunities to interact with faculty who have won major awards, who are pursuing knowledge in cutting edge fields. And those faculty want to engage with students. So when students don't connect with their faculty, when they don't reach out and build personal relationships with them, they are missing out on one of the most amazing relationships that they could ever have as far as a mentor-mentee relationship. So I urge them to take advantage of that by connecting with their faculty and getting to know them, getting involved in their research if possible, being a grader for their courses. All of those types of things help students build relationships with those faculty who can really open their eyes and encourage them to pursue their next giant leap.
Thank you. Okay, Avery. Your last words, but we also have one last question. What should new students do the first 30 days to be successful as possible?
Yeah, so kind of going off what was previously said, something that I personally wish I did a lot more within my first 30 days or with even just during my freshman year was just going to talk to my professors, whether it's after class or during their office hours, just getting to know them on a more personal level, especially because during those first couple of years, your classes will probably have 150 students in them, give or take. Your professors won't know your name unless you go and speak to them or you participate in class. And just being able to have that more personal connection can really get you far. Like, as was mentioned earlier, if you build that personal connection, you can be a potential future TA for their class. I know one of my better friends in college is actually one of the TAs for Dr. Thomas's class. So it really just building that personal relationship early on can help set you up for success in the future. And that's something that I personally wish that I had done when I started out as a student here, especially since the class sizes are larger, you have to make yourself known.
All right. Thank you. And thank you, everyone. That concludes our discussion tonight. Thanks again for all of you for watching, and we hope that you learned something new about the Department of Computer and Information Technology at Purdue. There are also many online information sessions and student-to-student chats. You can find information for all of those opportunities on our admitted student information page. Thanks again to all of our panelists for joining us and sharing their wisdom and experience. And you can join us. And if you joined us late, be sure to watch and replay because we talk about a variety of topics during the last hour. Thanks to Jessica Hoya for answering questions in the chat room. And especially thanks to John O'Malley, our technical director, for all the behind scenes and all of his work. As I mentioned before, please feel free to send email to techrecruit@purdue.edu. And if you have any additional questions for us about engineering technologies or Purdue, just a quick reminder, the deadline to accept your admission offer has been extended to May 15th. Thanks again for being here tonight. Have a great evening. Watch our men's Purdue basketball team in the Final Four this weekend and boiler up. Good night.